Gravity gets one big thing exactly right, and it is the scariest part. In orbit, ordinary junk becomes a gun. A bolt or paint fleck can hit like a bullet because everything is moving insanely fast. That is why the movie's opening catastrophe feels almost like a documentary. A Russian missile strike destroys a defunct satellite, and a debris field blooms outward. Mission Control warns the shuttle crew, but the warning arrives too late. The debris shreds the shuttle explorer, kills most of the crew, and damages Hubble. Two astronauts, Ryan Stone and Matt Kowalski, are left drifting, with only suits, tethers, and dwindling options. From there, the film asks you to accept a simple, terrifying idea. Low Earth orbit turns into a shooting gallery, and survival becomes a hop between lifeboats. Hubble, then the International Space Station, then a Chinese station, and finally a capsule home. The movie is brilliant at making you feel how small a human is up there. Yet it is also one of the most strained orbital maps in modern sci-fi. It gets the texture of orbit right, better than the geometry of orbit. Start with the most important realism, because it matters outside the theater. Orbital debris is genuinely catastrophic. At orbital speeds, even tiny fragments carry enormous kinetic energy. They do not have to be large to crack windows, punch radiators, tear solar arrays, or puncture pressure vessels. Gravity turns that into visceral horror, and it is not wrong to do so. The part that slips is timing and shape. The film treats the debris like a storm front. It returns about every 90 minutes, on schedule, over and over. 90 minutes sounds plausible, because many low Earth orbits do take roughly that long. The problem is the idea of a single coherent cloud, arriving like a circular saw blade that reliably intersects every important location. Real breakups create families of fragments. Those fragments spread into many related orbits. They differ in altitude, eccentricity, inclination, and phase. Atmospheric drag slowly changes some paths and leaves others lingering for years. The danger is real, and it can persist, but it is messy and statistical, not a punctual monster that comes back on cue right when the plot needs a ticking clock. A second key problem is even bigger because it powers the whole story. The movie treats low Earth orbit like a neighborhood. If you can see Hubble or the ISS, you can aim, drift, and get there. That is nautical intuition, and orbital mechanics is not nautical. In orbit, the hard part is not distance. It is matching velocity. Every spacecraft is on a specific track around Earth. Its orbit is defined by altitude, inclination, orbital plane, and timing. Two objects can look close, even seem to float in the same black ocean, and still be functionally unreachable. If they are in different planes, you are not just over there. You are moving in a different direction at several kilometers per second. Changing from one orbit to another demands delta V, a real change in velocity. Raising or lowering altitude costs energy. Changing inclination costs even more. Even a plane change of a few degrees at orbital speed can require a huge amount of propellant. And propellant is exactly what a spacesuit does not have. That is why the Hubble to ISS to Chinese station route is, in the chapter's words, orbital fantasy. Historically, Hubble's orbit and the ISS orbit are not the same kind of place. They were chosen for different mission needs and different constraints. A Chinese station has its own operational regime as well. Even if everything is low Earth orbit, that does not make it mutually walkable. Orbit is a set of high-speed tracks, and switching tracks is the expensive part. The film's propulsion tricks stack on top of that geography problem. Kowalski has a maneuvering unit, and later Stone uses a fire extinguisher as improvised thrust. The underlying physics principle is fine. Push mass one way, and you move the other way. In microgravity, an extinguisher really could scoot a person. But rendezvous is not just moving toward a target. You have to arrive with the right relative speed and the right alignment at the right time. Come in too fast, and you collide. Miss the timing, and you drift away as both of you keep falling around Earth. A handheld extinguisher is not a guidance system. A suit backpack is not a spacecraft stage. It lacks propellant, navigation margin, control authority, and life support time for big orbital transfers. Still, that extinguisher scene can be a great teaching hook if you finish the lesson. Newton's third law explains why you can move at all. Orbital mechanics explains whether that motion is enough and whether it is applied in the one direction that counts. Then there is the famous tether sacrifice, one of the film's most emotional moments. Stone is tangled in parachute lines near the ISS. Kowalski is tethered to her. He insists his momentum will pull them both away, and he unclips himself, drifting off to die. The physics of that moment is shaky. Once Stone is effectively stopped relative to the station by those lines, Kowalski should not keep feeling a persistent outward pull. In orbit, there is no gravity like downhill, dragging him away the way a cliff scene would on Earth. If there is remaining relative motion, the tether transmits an impulse, then the system settles. After that, it becomes a retrieval problem, not an inevitable sacrifice. There are versions that could make the sacrifice necessary. Maybe the lines are slipping or tearing. Maybe the system is rotating into a dangerous tangle. Maybe a thruster is stuck firing. But as presented, the scene asks you to feel inevitability, while Newtonian mechanics suggests it might be avoidable. Now, after all that criticism, it is worth saying why gravity works so well as a visceral experience. Its best science is not the map, it is the body. Microgravity motion is unusually convincing. People drift, rotate, overcorrect, and keep spinning if they cannot stop themselves. A small push matters, because inertia does not go away when weight does. The film lingers in long takes, so you feel continuous motion instead of edited motion. Even details like tears in these objects reinforce that nothing is anchored by default. That leads to an essential correction for students and moviegoers alike. Microgravity is not no gravity. The characters are still under Earth's gravity. They are in continuous free fall around the planet, and that shared free fall produces weightlessness inside the spacecraft. It is one of the reasons orbiting laboratories are useful at all. The sound design also respects space better than most action films. You do not get constant roaring explosions in the vacuum. Instead, you hear breathing, radio chatter, music, and impacts as vibrations through suit and structure. It is not pure realism because the score is emotionally forceful, but the choice is defensible, and it makes space feel indifferent. Catastrophe can happen with terrifying quiet. Inside the spacecraft, the movie is strong on engineering vulnerability. A fire is treated as an immediate emergency, which is exactly right. A spacecraft is not a room first. It is a life support system. Fire consumes oxygen, produces toxic gases, creates heat, and can knock out electronics. In microgravity, smoke and hot gases do not rise the same way, so ventilation and forced airflow become critical. A cabin can become lethal, even if the vacuum never gets in. Finally, the film nails the physiology of panic under constraint. Survival is a race against oxygen reserves, carbon dioxide buildup, cooling, communications, and cognitive overload. Stone's breathing gets loud for a reason. Hyperventilation wastes oxygen. Rising carbon dioxide can cloud thinking and amplify distress. Exhaustion and grief narrow attention until even simple procedures become hard. That is where the movie's emotional arc and scientific reality meet. Courage is not just boldness, it is the ability to regain task focus while your body is shouting that you are dying. So here is the takeaway to carry into every space movie after this one. Gravity looks like a story about flying between nearby lifeboats. In real orbit, the lifeboats are on different tracks, and the real enemy is the price of changing tracks.